All right, continuing our work with systems, today we're going to look at applications of systems of equations. So how can we use a system of equations to represent and solve a real world scenario, a real world problem? And so the way you want to do these is first make sure you read through each problem completely, read through the whole thing, and then once you figure out what the variables need to be, so what you're trying to find, define those variables and tell what they stand for. And then we'll write two equations and solve the system that we write. Okay, so number one here says Rachel and Naya went to Mary Lou Donuts on their way to school. And then it says Christy bought 3 donuts. So I think this is a typo. That is supposed to be Rachel bought 3 donuts and 1 cup of coffee and spent $8.25. Naya bought 1 donut and 2 cups of coffee for a total of $12.75. Find the price of each donut and each cup of coffee. So what we're trying to find here is the price of each donut and the price of a cup of coffee. And so that is what our variables need to stand for. And so what I like to do is use a variable that's going to represent the thing I'm trying to find. So I remember which variable stands for what. Of course, you can use any variable you want. You could use X and Y, but I'm going to use D and C here because that will give me really clearly what each one stands for. And so that's what I like to just jot it down in the problem. You could also write, D equals price of 1 donut. C equals the price of 1 cup of coffee. But if you're just doing this work for yourself, that's not usually necessary. You can just write D and C like this, and that will help you remember what stands for what. All right, well, now we have to write the actual equation. So in a problem like this where you have 2 people going shopping, essentially, you can write an equation that just totals up what they buy and the quantities of what they bought equal to their total bill. So for Rachel, we have an equation that's going to be 3D, that's 3 donuts, plus 1C, that's 1 cup of coffee, and that's going to equal $8.25. And then for Naya, she bought 1 donut, that's 1D, 2 cups of coffee, and a total of $12.75. So there we have a good system. We have an equation for each person representing their total bill and what they bought to get there. So now we have to solve this using any method that we like. I would recommend elimination typically. So to do that, I'm going to multiply this top equation by -2. That'll give me -6D minus 2C equals -1650. And then, of course, to solve this, we're going to add these equations together. The C's cancel out, so I'm left with -5D equals. Now we have to do some decimal math, and it's always handy to have a calculator near you so you can do this quickly. We get -375. All right, now just divide by 5. And we end up with 75 cents. I should have divided by -5. But we get 75 cents here for the cost of 1 donut. But now we have to find the price of a cup of coffee. So let's just put that maybe into the second equation here where we have 1D. So D is 75 cents plus 2C equals 12.75. Subtracting 75 cents from both sides, we get 2C equals 12, and so C equals 6. A cup of coffee equals $6. And there's our solution for the problem. If I was formally doing this, I might write out 1 donut is 75 cents, 1 cup of coffee is $6, but this is good enough for here. Notice I don't have my solution as an ordered pair because we're not talking about a graph, although we could graph this certainly, and the ordered pair would be 0.756, but for a word problem like this, for a real world scenario, you want to quantify the answers in the terms that they're given in the problem. Okay, Mr. Preston bought 20 boxes of cookies for students with Bronco points. A box of chocolate chip cookies costs $7, and a box of oatmeal raisin costs $5. If he spent $126 total, how many boxes of each type of cookie did he buy? Okay, so we have what our variables stand for right here. How many boxes of each type of cookie? That's going to be what your variables stand for, is what you're being asked to find out typically in these problems. So we can write an equation. First of all, we know that he bought 20 boxes of cookies. Okay, so let's say I use C for a box of chocolate chip cookies and O for a box. Actually, I'll use R because O kind of looks like a 0, so I'll use R for a box of oatmeal raisin. So we know that the total of these two boxes is going to add up to 20. So that's our first equation. The quantity, C plus R equals 20. So I know he bought 20 boxes total. R is the number of oatmeal raisin boxes, and C is the number of chocolate chip boxes. So the total must be 20. And now we can have an equation where we apply the cost of each thing to those. So 7C, $7 per box of chocolate chip, plus 5R, and our total cost was $126. So we have one equation. Let me scoot this over. We have one equation that is the quantity and one equation that deals with the price. So oftentimes you'll have this type of system where you have an amount equation and a price equation. All right, but we still have to solve it. I'm going to use elimination again. Although this is not bad for substitution. You know, you could say C equals 20 minus R and plug that in, but I'm just going to use elimination because that's my go-to method typically. So I'll multiply that top equation by -5. So -5C minus 5R equals -100. And I could have done -7 to cancel out C. Multiplying by 5 just feels nicer to me. So if I add these together, I get 2C equals 26. Well, C is going to equal 13 then. And if I plug that back in to find R, if C plus R equals 20, that's 13 plus R equals 20, then R must be 7. And given the popularity of chocolate chip versus oatmeal raisin, I think this sounds about right. So there are 13 boxes of chocolate chip and 7 boxes of oatmeal raisin. And I went ahead and wrote that out more than I did in the first problem, which is typical. You might give a little bit more information in your answer here. All right, moving on to number 3. The concession stand at the Jeff basketball game sold 230 drinks during the last game. Sodas cost $1.50 each and Gatorades cost $2. The concession stand made $370 total. How many of each type of drink did they sell? This is pretty much exactly the same setup as the previous problem with the cookies, the boxes of cookies. So we know they sold 230 drinks. And we're looking for how many of each type of drink. All right, well, I'll use S, even though I don't love using S because my S's look like 5. So I'll use S for sodas, and I'll use G for Gatorades. But I'll probably use lowercase on these. So, okay, so the first one, again, is our quantity. We know we sold 230 drinks. That would be S plus G equals 230. The number of sodas plus the number of Gatorades has to equal the total number of drinks sold. And now we can apply the prices to it. Sodas are $1.50. That's 1.5 S. I'll put a 0 on it, 1.50 S. Plus the $2 for each Gatorade, 2G, and that equals $370 total dollars. Now again, I can do elimination here. And I could multiply by -2 to cancel out the G's. And that's probably what I'll do. I don't really want to multiply by -1.5. So let's do negative 2 here. So I get negative 2s minus 2g equals negative 460. Adding these together, you get negative 0.5 s equals 370 minus 460. What is that? Negative 90. So if I divide by negative 0.5, that's just multiplying by 2, I get positive 180. And you can always use a calculator. Negative 90 divided by negative 0.5, we get 180. So I know we sold 180 sodas. And now, as always, to find G, just plug that back in. 180 plus G equals 230. Subtract that, we know we sold 50 Gatorades. 230 minus 180. So our solution is 180 sodas, 50 Gatorades. I'm not sure how accurate that really feels as far as realistically, but it could be, especially if sodas are 50 cents less. Okay, and last one here, number 4, says 6 glue sticks and 7 crayons weigh 167 grams. 2 glue sticks and 8 crayons weigh 84 grams. How much does 1 glue stick weigh? How much does 1 crayon weigh? So we want to find the weight of each one. Glue sticks will use G, crayons will use C. And this one's pretty straightforward. This is honestly very similar to this shopping problem with the cups of coffee and the donuts, only instead of shopping, we have weight. Glue sticks and crayons adding up to a certain weight. But the setup is very similar. We have 6 glue sticks, 6G, plus 7 crayons, 7C, and that is equal to 167 grams. Okay, now we have 2 glue sticks and 8 crayons equals 84 grams. All right, so it's just the amount of each thing multiplied by the variable and then equal to the total weight. Now to solve this, it looks like I can multiply this bottom one by negative 3. That'll give me negative 6G minus 24C equals negative 252. Go ahead and check that. 84 times 3, 252. I want to add that together with my first equation, which is 6G plus 7C equals 167. And I'll just bring that down so it's easier to see what I'm adding together. Okay, the G's cancel. I've got negative 17C and then negative 252 plus 167. Anytime you don't feel like doing an addition problem like this in your head, use a calculator. It's a lot faster. Equals negative 85. So all I'm doing is dividing by negative 17 then, and we get 5. So a crayon weighs 5 grams. Now to find the weight of a glue stick, we're going to put 5 in for C in one of these two equations. Doesn't honestly matter which one. I'll use this one because 5 times 8 gives me a 40 instead of a 35 on the other one. So it's just easier to work with a 0 than a 5. But honestly doesn't matter. Okay, so 5 times 8 is 40. Put 5 in for C right here. And that equals 84. Subtract 40, we get 44. And divide by 2, G equals 22. So in our problem here, a crayon weighs 5 grams, and a glue stick weighs 22 grams.